So for this problem, to find the interval or the intervals where the function is increasing and where the function is decreasing. So for this given function, so first, we need to find the first derivative. So we have the f prime of x equals the derivative of 2x to the power 3. So multiply 2 times 3, this is 6, then x minus 1 for the exponent to the power 2, then plus the derivative of 3x to the power 2. So 3 times 2, that's 6, then x minus 1 for the exponent, so to the power 1, then minus the derivative of 36x, so just drop this x, so this is equal to 36. Then equate this to 0, so we have 0 then equals 6x squared plus 6x minus 36. Then observe that these numbers are divisible by 6. So divide every terms by 6. So this becomes x squared, then plus. So we have x, then minus 36 divided by 6. So we have 6, then equals 0. Then from this quadratic equation, so we can solve for x using the quadratic factoring. So the factors for x squared, so that's x times x. And the factors for negative 6, this is 3 times 2. Since the middle term is positive, so therefore the bigger number must be positive. So this is positive 3, negative 2. Then to solve for x, so equate these two factors to 0, and x minus 2 equals 0. So we have now x equals negative 3, and the other one, x equals positive 2. Then put now these critical values in a number line. So in a number line, this one is 0. So the negative 3 on the left of 0 and positive 2 on the right of 0. This is negative infinity and positive infinity. So we have now the three intervals. So the first interval is from negative infinity to negative 3. The second interval, so from negative 3 to positive 2. And the third interval, so from positive 2 to positive infinity. So to find out the interval or the intervals where the function is increasing or decreasing, so from the first interval, so that's negative infinity to negative 3. Then this time, using the first derivative, and we need to replace now x with the value between negative infinity and negative 3. So we can use negative 4. That's between negative infinity and negative 3. Then from this first derivative, so we have f prime of x equals 6 times x is negative 4 plus 6 times negative 4 minus 36. Then this becomes 6 times negative 4 to the power 2. This one is 16. Positive 6 times negative 4, that's negative 24. Then minus 36. And this 6 times 16, this is 96. Then minus negative 24, negative 36. So we have 60. So therefore, the f prime of x equals This is positive 36. So since the result is positive, so therefore this interval is increasing. Then from the second interval, so we have negative 3 and positive 2. Then we need to assign x the number between negative 3 and positive 2. So we can use 0 as the value for x. Then from the first derivative, so we have the f prime of x equals 6 times 0 because x is equal to 0. Then plus 6 times 0, then minus 36. This one is 0, this one is 0. So therefore, the f prime of x equals negative 36. So since the value is negative, so therefore this interval is decreasing. Then the last interval, so we have from positive 2 to positive infinity, then we let x equals the value between positive 2 and positive infinity. So we can use positive 3. Then from the first derivative, so we have 6 times x is 3 plus 6 times 3, then minus 36. So this becomes 6 times 3 to the power 2. This one is 9 plus 18 minus 36. And we have 54 plus 18 minus 36. So we have now the f prime of x equals, so 54 plus 18, this one is 72. 72 minus 36, so we have positive 36. So since the result is positive, therefore this interval is increasing. So the interval where the function is increasing, so this is negative infinity to negative 3 and positive 2 to positive infinity. Then the interval where the function is decreasing, so that's negative 3 to positive 3. Then for this problem, so first we need to find the first derivative. So we have the f prime of x equals, so using the power formula, so bring down this exponent times x squared minus 9, then minus 1 for this exponent, so to the power 1, then times the derivative of x squared, that's 2x, and the derivative of a constant, this one is 0. Then to simplify, so multiply, this is 2x squared. 2 times negative 9, this is negative 18. Then times 2x. Then we have f prime of x. So 2x squared times 2x, this is 4x to the power 3. Negative 18 times 2x, negative 36x. Then equate this to 0, so we have 0 equals 4x to the power 3 minus 36x. Then observe these numbers divisible by 4. So we have x to the power 3 minus 36 divided by 4. This one is 9x equals 0. Then we can factor out now this x. So put 1x outside. So the remaining is x squared minus 9 then equals 0. And to solve for x, so we have x equals 0, and the other one, x squared minus 9 equals 0, and we have x squared equals transpose, that's positive 9, then take the square root, so we have x equals positive and negative 3. So we have these three values for x, 0, positive 3, and negative 3. So in a number line, to find the interval, so this is 0, then we have this negative 3, positive 3, this is the negative infinity, and the positive infinity. So the first interval from negative infinity to negative 3, then we also have negative 3 to 0, and 0 to positive 3, then also positive 3 to positive infinity. So from the first interval, so that's negative infinity to negative 3, then we let x, the number between negative infinity to negative 3, so we can let x equals negative 4. Then from this first derivative, so we have f of x equals 4 times negative 4 to the power 3 minus 36 times negative 4, and we have 4 times this negative 4 to the power 3, this is negative 64, then negative 36 times negative 4, so this is positive 144. Then to simplify, so this positive 4 times negative 64, this is negative 256, then plus 144. So therefore, the first derivative equals, so we have this negative 256 plus positive 144. So the first derivative is equal to negative. So since negative, so therefore this interval is decreasing. Then from the second interval, negative 3 to 0, then we let x, the number between negative 3 and 0, so we let x becomes negative 1. So from this first derivative, so we have 4 times negative 1 to the power 3, then negative 36 times negative 1, and this becomes 4 times negative 1, positive 36, and this is negative 4 plus 36. So we have now the first derivative equals this negative 4 and positive 36. So the result is positive. So therefore this function is increasing. Then from the third interval, so we have 0 and positive 3. Then we let x, so between 0 and positive 3, so we let x equals 1. So we have now f prime of x equals 4 times 1 to the power 3 minus 36 times 1. So this becomes 4 minus 36. So therefore, f prime of x is equal to negative. So therefore, this interval is decreasing. Then the last interval, so from negative 3 to positive infinity, then we let x equals to a number between positive 3 and positive infinity. So we let x equals 4. Then from the first derivative, so this is 4 times 4 to the power 3 minus 36 times 4. And this becomes 4 times 64 minus 144. Then 4 times 64, this one is 256 minus 144. So we have now the first derivative equals 256 minus 144. So this is positive. So since positive, so therefore this function is increasing. So therefore, the function is increasing if the interval is negative 3 to 0 and positive 3 to positive infinity. Then the function is decreasing for the interval negative infinity to negative 3 and 0 to positive 3.